So yeah, introducing myself, I'm going to talk today about Pocket Protector, secrets as code. Sounds very mysterious. So secrets, what are secrets, right? What are they? What are they? Well, I mean, in a developer context, it's a little bit different than in a real life context. So I thought I should start out by sort of contrasting family secrets versus dev secrets. This way, you know, we can all relate because we've all got family secrets, right? There's a Wikipedia article on family secrets, and it must be notable as a result. So family secrets. First off, they're great for parties, right? You're playing truth or dare, right? Like you go for truth, right? And you just like you hit it on the head, and you're the gossip of the town. And you know, it's a fun way to burden all of your friends. It's a fun way to burden all of your friends with you know, wonderful information that is going to sort of struggle to keep under wraps. Because once you share it, you're going to regret it always, right? You know, it was fun for everyone else at the party, not so much you. Yeah, because we all know what you did last summer. So yeah, basically, that's family secrets. How do you handle them? You try to forget, right? You crack open a cold one, and you know, you just try. Now this is different than developer secrets, right? Developer secrets, they come with the job, right? And you're actually paid to keep those. But you know, they're terrible at parties, right? If I start going like A, D, 0, B, and I just start like, you know, it's not going to be a hit. It's not going to work. But they're super useful otherwise, right? And that's actually why we share them thousands of times a day. You know, we use them, we share them. You know, shared secrets are very important to you know, software. And that's also why we change them all the time. Right? If only we could do the same with our family secrets. So let's make them work, right? And you know, but unfortunately, like, yeah, I mean, we need them. Developers, we need secrets, right? We need them for our database passwords, right? We need them for our API keys and our tokens. We need them for SSL certificate passphrases. You are encrypting your SSL certificates, I hope, and more, and more. So. But the thing is that, like, you know, the secrets are tough to manage, right? And that's why basically every secret starts with mismanagement, right? First thing you do is you put them in the code, right? This is the easiest and earliest form of integration, right? Hopefully you trust GitHub or wherever you're hosting these things, and also everyone at your company, and like every piece of hardware and all this stuff, right? It's very sloppy. That's why approach number 2, somebody's going to say, like, you know, we actually need multiple secrets, you know, some for dev and some for prod. And so let's put them in different configs, you know. And someone's going to be like, well, wait a second. A settings.py and the config.json, that's not much more secure than the code, right? Eventually, I'm going to have to check that in. And depending on our configuration management, right, now I've probably got 2 problems. I haven't really solved the secret problem. And so the other thing you can do is you can put them in the environment. You know, you can just pop them in there every single time, and you're going to get tired of entering them, and you're probably going to mess up enough times that you put them somewhere, and then out it goes, right? You regret it. You're going to lose them. So what do the good options look like, actually, right? So I've seen people take a variety of approaches that are not blatant mismanagement. The first of which is to use a password manager. Right, so many of us. How many people here use a password manager in their browser, like LastPass or KeePass? Yeah, but see, and these are actually pretty good, right? Pretty good. But the problem with these in a professional setting is that they focus on an individual consumer, you and your browser, and they don't work great for teams. They just don't. So what you can do then is take an enterprise solution, a key management service, something like HashiCorp Vault, or you know, a hardware security module that's thousands and thousands of dollars and needs to run in a cluster in a data center, etc. The problem with these enterprise solutions is that they don't scale down. Best you can do is basically have them running in Docker containers locally or something like that. So there is a third option in this Goldilocks type scenario, right? And that's encrypted source control. So maybe someone here has used Gitcrypt. Gitcrypt? Anyone? No one. Wow. Okay. Here I was thinking stars meant something. All right. Yeah, Git crypt and friends, they scale down because everyone who has a copy of the code can then like sort of encrypt things, but they're not really built specifically for secrets. And as a result, like you can use them for any file, and it doesn't really care if it's secrets or not. And so it's kind of cryptic to use and thus easy to misconfigure, which is basically all you need to make a foot gun. So there's got to be a better way. Imagine this is a black and white GIF of somebody spilling milk. All right. And to solve it, we created Pocket Protector. It's pocket-sized secret management. And like I said at the beginning, it's secrets as code. So I see a few people here who are probably old enough to remember the bad old days of CI when you had Jenkins that you had to manually paste bash scripts in your browser, and you had to basically, I see some people smiling because I know they still use them, right? And this is great when like you have a one-liner or two-liner, but eventually for some reason that config always ends up being hundreds of lines, and you're like, well, gee, I sure wish I had a way to, you know, save the various versions of the script that I'm creating by pressing save config over and over again. But see, that would require, like, you know, being some sort of C genius in order to write a command. Basically what happened was people realized that this is a big source of friction, right? You know, as much as I love BuildBot, right? BuildBot and Jenkins are this old generation of CI, and these days, if you use Travis or use Circle or you use GitLab, as we do, then basically your CI config lives in a dot file in the code, right? And you just sort of like can ride that version control train all the way to productivity town, you know? And you basically just have a YAML or something in there that like you can do a blame on, and you just update it, and eventually you have a working config and you merge the branch and everything is hunky-dory, and you never have any sort of like confusion as to whether the config matches the code because they're together. Pocket Protector does this for secrets. We were talking about secrets. It lets you safely and explicitly manage these secrets in repo. Now I was a little bit nervous about the concept starting out too, right? Like I'm about to put these secrets, which I just said are not safe to put in code, right next to my code. How do we keep these things safe? Why, with state-of-the-art encryption, of course. We've got Argon 2, which is a CPU and memory hard password hash. We've got Curve 25519 2-key. We've got basically everything that we need from the NaCl sort of secret box type industry standard, but very modern implementation. And most importantly, it's productified, it's productionalized, it's a product. It lets you do multi-user and multi-environment, people-driven secret management. Now this is too good to be true, you say. Well, almost. It is true, though. In order to explain how we do all this stuff, though, I'm going to need to introduce some concepts. So for one, we have domains. Domains are just namespaces. We all use Python. We love namespaces. It says so in PEP 20, right? We should do more of them. And Pocket Protector has namespaces, which lets us organize our keys by app and environment. So you can have keys for dev right next to the keys for production, and it will still be safe. We have key custodians. These are effectively registered users. Now here's where things get kind of weird. Basically, in a security type scenario, anyone can actually write a secret, right? Now, usually people are thinking like, well, write is actually a heavier duty permission than read. So really, is it safe to let anyone write to it? The fact is that you already have security in place to avoid people unauthorizedly pushing to your repo, writing to your repo. You have that functionality already, so Pocket Protector doesn't second guess that. Instead, what we do provide is we provide an ability to register users who can have passphrases to read from a file. Reading is the big thing here, getting that secret out, sharing it at the party. You don't want it. So we have owners, right? These are key custodians who are going to have read access to a particular domain. This allows us to separate people who have production access from people who have local dev access, right? Your local devs, they can be owners on the dev domain, and you have production owners for the production domain. Okay, so I said it was simple. Maybe those concepts are a little bit tricky, but I said it was simple. It all fits on one screen. I'll walk you through it real quick. So how do you get started with Pocket Protector? Doesn't get much easier than this. Just like Magic Wormhole, you pip install it. Pip install pocket_protector will get you what you need. A couple seconds later, you're ready to start your first protected file with your first key custodian. So you do pocket protector init, and then you enter sort of a login, a user email, right? Alice@example.com will be our CTO making the right decision in this case. She's going to enter a passphrase and type it again, and she'll be off to the races. Ready to add her first domain with its first owner. So basically, when you create a domain, it asks you for that login to make you an owner implicitly on that domain. And finally, we're ready, now that we have our owner and our domain in place, to add a secret. I added a secret to the dev domain named API_key. The value is scalable as best as I can write in hex. Yeah, basically, you'll notice here, like I said, you don't need login information in order to write to the file. Anyone can write to the file, but not everyone can push to the repo, I hope. For you. We don't let everyone push to the repo. So now let's see if the reading works as expected. If I do pocket protector decrypt-domain dev, the domain to which I added a secret, and I just enter my email and passphrase, I will see a JSON serialized version of the domain that I just set. And with all of that done, I have a protected file that is ready. Oh, one more thing. So these credentials here, some of you might be thinking like, well, it's pretty inconvenient to have to type it on the command line every single time, even if it is in a secure fashion using the password module in Python. But the credentials actually can come from standard in, as in this case, which is useful for some local dev. But more realistically, they can come from environment variables, which is what Heroku and GitLab CI support. Or even more securely, they can come from a mounted file, which is how Docker Secrets does it. That way you don't accidentally dump your environment in a debug and leak your secrets. And with all that in place, we are finally ready to do git commit protected.yaml and do a push. And there we go. Our secret is now secure in the cloud. Everything you want. And you're basically done. Cheers from the crowd. No. Yeah, so now under the hood, what's going on here? I feel like some people are a little bit skeptical. Let's take a look. So this protected.yaml, as suggested by the file extension there, is in fact YAML. And when we look at it, we'll find that it's compact, readable, and Git blameable, right? This way you can tell who did what. And you can use fancy Git features to PGP sign all of your commits if you want to be extra super secure. But looking inside the YAML, again, everything we did fits on the screen. We see that we have our dev domain with an API key here. Alice is an owner on the dev domain. She's also registered as a key custodian for the file. And there's an audit log of what happened. We created that key custodian, we created the domain, and we also added the API key to dev, just for easy reading. I mean, the hex, the base64 stuff's not so easy to read, but that's intentional. And so there's a lot more to Pocket Protector, right? So basically, we have quite a few things that you might want to do in a secure environment, right? Somebody comes to the company, somebody leaves the company. You want to be able to remove owners or delete domains and sort of modify this file. And all of this stuff is wrapped up for you in a handy dandy Python command. You may need to update a secret or rotate keys. All of that's built in. Maybe you just want to view the audit log. That's there as well. You think of it, and we will probably add it. Speaking of,
the audit log is checked into source control. I can just delete random lines from it and check that in, right?
So there's a question here. The question is, can you delete random lines from it? And the answer is yes. And then your boss will see the Git history, and having hired you as a good faith employee, they will be very disappointed, and consequences will ensue. But the lucky thing is, it's also got a history, right? So if you can force push over that history, well, they got no one to blame but themselves, really. I hope.
Really?
Right, they can Git blame themselves. All right. So yeah, next steps for Pocket Protector are, right, today I can safely state that it is way better than the alternatives. It's way better than hard coding stuff. It's way better than putting it into some like plain text JSON, and it's way better than trying to keep track of environment variables, especially as you add more and more secrets. Those things are going to start numbering in the dozens, and it's going to be very unwieldy to handle. And I can also say that we are currently using it now for almost 2 months in a multi-app, multi-environment sort of use case here at Simple Legal, right? So, you know, the 100+ clients behind the sheets here all trust us, and we have this. And yeah, it's available on PyPI and GitHub. If I have a second after, I haven't been watching the clock, but I can demo it for you in that respect. So, upcoming features, right? Right now, if you lose that file or forget your passphrase, then that data is as good as gone, right? Like that's how good encryption works. You forget the passphrase, and it's totally unrecoverable. That's intentional. However, in a team-like setting, right, and we're all a team, and we don't want to have to blame, you know, Mahmoud for like completely destroying the site by forgetting his passphrase. We are planning on creating basically recovery pools based on Shamir's secret sharing. So the way that will work is that you have enough owners that you have sort of a quorum that if maybe one person forgets, 3 others can remember theirs and then break glass on the domain and reconstruct the file. These things happen. We're only human. So we figure we should support that sort of thing. We'd like to support more types of secrets. Currently, we just support sort of the token, which is enough, right? But maybe we want to support some type of signing or something like that. So we're looking at that. Also, we have a fancy new CLI in the works. There's a PR out for that that's going to move off of argparse because argparse is really not good at subcommands. So yeah, that's how that works. But yeah, I can definitely say try it out. And if you'd like, here are the links: Pocket Protector, Face, and here's Shamir's secret sharing, where actually the Python code on that page is like, you know, the reference one on Wikipedia because we wrote it, and we significantly enhanced the Wikipedia article and fended off any sort of you know, radical page blankers or whatever. And yeah, if you are using it though, we are planning some of these changes. So just shoot me an email, right? And we can make sure to coordinate and maybe even build some features that'll work for everyone. And if you like these slides, I do plan on putting them up on my website. So yes, questions? Moshe.
Do you have API access, like published API for that?
So right now, the primary API that even we are using is the CLI, right? It's sort of like pip in this regard. However, I don't think that there's anything that necessarily, yeah, there was some fun drama about that lately. I don't think that there's any reason why we wouldn't. If Kurt is around, maybe he can. Yes, Kurt?
Sure, yeah.
You seem to have thought long and hard about this. Yeah. No, I imagine a library access will make sense. Right now, we only support the stuff from a protected.yaml, right? But there may be other formats we want to support down the line, and so turning it into a library definitely makes sense to me. Yes, Greg.
So appending things onto the end of a file is a little dangerous with Git because you can end up with conflicts that are not conflicts.
Sure.
So how does that work in practice? If I've got 10 secrets in a file and 2 people update it, they're going to collide all the time.
I mean, hopefully, like you aren't doing this. I mean, I say rotate your keys often, but not that often. You know, like every 1 to 10 seconds or something like that. In general, right? Like Git seems to work for probably a couple million developers or something like that for like conflict resolution, and the tools built into that, especially with like in conjunction with GitHub and GitLab and so forth, are going to help you resolve those sorts of conflicts. It is sort of, I guess, possible, but then you always have the option of reversion too. You know, I think that we also have like a way to validate, like you can load the file as well, so you can maybe have a CI on changing this. Is another way to sort of guard against that sort of thing. So it's a valid concern, but hopefully not one that would come up too often. In reality, right, like production keys are probably only going to be written by a few people, but I guess one use case that is supported by this is kind of interesting is that if I'm working on a feature that needs a production key and I write it to the file, coworkers at my level don't necessarily have access to it. So it can be sort of treated like a secure channel. Everything's going over, everything's being encrypted, going over SSH, going over HTTPS, having login in like a private repo, you know. So I think it'll be okay for collaboration. Yes.
Does this comply with PCI rules?
You know, I guess probably not. Like the let's see, PCI. There's very little PII here, or anything like that. And I'm not really sure if Argon 2 has been like FIPS.
Yeah. That's the algorithms we use. We probably need to use like RSA or the big element DCH or something like this.
Yeah, man. The regulations just don't move fast enough for silicon.
Whether that violates any of the PCI rules or not. Just the fact that you are exposing.
Oh, exposing it by.
I remember rules with PCI where a key had to be in a safe of a company, signed by CEO and another person who is signing off firstborn and.
Sure, the old security blood pact. I'm familiar. I used to work at PayPal. No, it is interesting. It is interesting, like how some of the PCI stuff is. I don't think it's safe to say this is like PCI certified right now. We can probably look into it a little bit more. Yeah.
We used to work at PayPal, and I don't know, it's not try to say like it's very similar mechanism. It's just like it's older because it was made in 1998 and stuff like this. Same kind of concept. You have like this like file that contains encrypted secrets that lives right along with your code, and they're definitely PCI compliant. So in general, like this approach, there's nothing too wrong with it.
Yeah, the curve that I mean, it's weird because the curve that they're using is very old for a lot of this stuff. I think that they got off of it maybe if they followed directions, but they were using up until 2016 a curve that was as old as like 1998, right? So
yeah, the rules that on one hand say everything I just mentioned, and on the other hand you need to have a password in the Wi-Fi.
Sure.
Discrepancies of that sort.
Mm-hmm.
Of course you need to have a password.
So actually, how are you looking at it? So in all seriousness, because both PCI and PCI2, that's already been the context you already established. So now you're being aware of it. So you've been warned now. So how do you actually? How does an organization, beyond an individual, take that risk? How are you actually thinking about it? I'm actually interested in your, you guys that are actually more responsible for it, for this project. How would you warn people that, hey, what do you want to use it for, and what is it not safe, and because it's not being, let's say, static. I'm not saying this static analysis and a bunch of other stuff. I'm from the embedded.
Sure.
So security analysis, and how are you actually now thinking? Now you have been warned, which is different than you can be actually audited. You can pass audit before, but you're only as good as your next audit.
That's true.
That's actually how. So we now have been warned. This is just this gentleman just did.
So I mean, given that we don't do any payments processing.
No, it's not about payment. I'm not trying to say this is about payment.
Sure.
How are you now thinking about, pursuing the, what do you want? What would you want this project to tell people? What do you not want to use this for?
Right. So I mean, I guess like I said, we sort of publish which algorithms we use. All of that is like in the dependencies and the README, and there is a user guide online as well. It's sort of like his intention is kind of like towards smaller startups, not necessarily to a say like a payments company, which is going to have an audit for PCI. But yeah, I guess like a warning along those lines is in order. But yeah. As far as static analysis goes, CPython performs amazingly at that sort of thing. So we feel very good about having developed it on top of Python. And I think that it's like NACL library is like going to undergo a lot more of this stuff very soon, because Curve 25519 is starting to look more and more like the only secure future. Like it was like was it like 2 years ago now that they removed the recommendation for like the beta suite or whatever it was, the B suite, what was it called? Is that sort of coming back? Yeah.
And then you have the N6 and you're like, oh, well, I thought
Yeah. Yeah. So yeah, I mean we're like we feel very secure in this, right? This is like a very secure part of that. This is more secure than probably OpenSSL.
Low bar.
It is a pretty low bar. It's a pretty low bar. But I mean it is also part of like, you know, the stack and so forth, right? So yeah, it'll be interesting to see how time bears this out. Okay. There are no, I mean, Rory?
I just have a, so this seems pretty simple, but is the implication that you got to keep this file secret, right? Because if someone had that and they could just correct the passphrase, right? That's
No. No. So basically, you can leak that file, and you know, you can put it on a billboard, and not for a trillion years are they gonna like, you know, be able to crack it with current like computing technology.
Because all I gotta guess is your passphrase, right?
So it's a CPU and memory hard like, you know, passphrase. So like if I can do a demo now, it's gonna like have to really chug in order to process the passphrase.
Move machine to your script.
My favorite password is password. I mean, if I use that, would they be able to crack it?
Yes.
Yeah, sure.
Yeah.
Because I can remember that, right?
Well, use good passwords.
Yeah, this is not gonna yeah.
How much stretching? Like it calls?
How much what?
Stretching, like the Argon 2 stuff. Is
Oh,
a couple seconds, couple megabytes.
It-
or more or less?
Right. The parameters are in here. I can probably pull them up, or we can do it offline as well.
Just when you're using it, did you wait like a couple seconds or a couple minutes or a couple hours?
Yeah, it takes a few seconds.
Seconds. Okay.
Doesn't do it hours. Gotta keep it usable. Yeah.
Do you have docs inside the repo for the kind of architecture, like what the crypto is like? Or do you
Yeah,
have the source code for that?
the source code is there, but like that part of the docs is something that like is sort of being worked on, I guess. Right now, like I sort of focused on like kind of the user guide and kind of almost the more operational security like aspects of it, since that's probably that's why I have the most concern as well.
So if you start developing off a different machine, you can no longer access this file, and kind of confused them.
Oh no, like you push it up to the Git repo, the next other person pulls it down with the rest of the code, and then they have the file too. It solves the distribution problem by keeping it with your code.
No, the point being that if your key and passphrase is tied to your hardware, maybe I'm missing.
No. The passphrase is one that you choose, right? And then you have multiple users, each with their own passphrase.
So if I set up a new machine, if I already set up, I already have the key set up, I push some stuff, that machine catches on fire, I have to set up a new machine. I start by doing a git clone, I type in the same email address, I type in the same passphrase, and now I get back on my stuff.
Yes.
Okay.
So they do have to just guess your passphrase.
That they do. Yeah. In my case, it's 3 letters long. We might want to warn about that. Let's see. So, like, yeah. I'm kind of surprised that such a thing didn't exist before. I looked around for quite a while, and Git crypto is the closest thing.
There's Ansible Vault, but it does not play anywhere near as well with source control because it encrypts the whole thing.
It encrypts the whole thing.
So then, like conflicts are just.
Yeah, exactly. So by keeping it text-based, like conflicts are going to resolve much better. All right. What is the thing to like? I guess add a secret like we're going to see how long it takes on my machine to Argon 2 decrypt it. And the secret name is API key and the values.
Could you pop up the font just to-
Yeah, you got it, boy. All right. So I'll even do you one better.
And when you add a secret like that, it automatically encrypts it to your own personal key.
Say again?
When you add a secret like that, it automatically encrypts it to your own personal key.
To my own personal key.
I noticed you didn't type in the passphrase when you did the add secret.
Yeah. Every domain has its own sort of secret.
So there's a public key floating around in the local environment that it encrypts stuff to.
It's in the file, not in the local environment. So let's see.
Just give me the password.
It is basically, I guess. So No. And there you go. All right. So, in and out, it's not just the slides. It still works. I know because it works in the Kubernetes too. So it's got to work. Yeah, and that's that. Not a heck of a lot to it, right? Like, here's the file again, right? Line based. It should work nicely. Cameron?
So if I wanted to contribute to this and maybe change the method of encryption to something that's known by the giant committees that create PCI compliance regulations and other similar security documents, how easy would that be? If I just wanted to
We'll have to add like a flag or something. We'll have to put that stuff into the file. It is technically, if you look, like everything here starts with an A. There is like sort of a versioning bit in there, right? And we can communicate that metadata, so we'll have like a future path. But yeah, I don't think that's in scope right now.
Okay.
Yeah. All right, I'll take the rest of it offline and so forth. I gotta let Barry get up here and do his piece. But yeah, no, thank you all for being my auditors tonight.